For the second question, the first question is that for the Yson stationary process, we can see that the Yson stationary process must satisfy these two conditions. The first one is that the expectation of x of t does not depend on t. That is to say, ext is a constant. And the second is that the autocorrelation RT1 T2 is which is equal to E x of T1 x of T2 must only depend on tau, which is equal to T1 minus T2. And for the Markov process, we suppose that T1 is larger than T2 and larger than Tn. The property of the process is that the probability that x of T1 less or equal to x1 on the condition that x of T2 is equal to x2 and x of Tn is equal to xn is equal to the probability that x of T1 is less or equal to x1 on the condition that x of T2 is equal to x2. So we can see that for a Markov process, if the function that f x1, x2, t1, t2 is enough to characterize the whole statistic process. And for the Strickson stationary process, we can define it as the nth order statistics of x of t is independent of time shift. So we can express this idea with a math formula: fx1 to xn, t1 to tn is equal to fx1 to xn, t1 plus c, t2 plus c2, tn plus c. And this is true for any c and xn to x1 to xn and t1 to tn, and for any n, this formula must be true. And for the white noise, we can express that as nt, and it has to satisfy the property that nt1 and nt2 are uncorrelated when t1 is different from t2, and the correlation c t1 t2 can be expressed as this formula must be 0. So we can the c t1 t2 is equal to tq t1 the impulse t1 minus t2.